Okay, so in this class, we're going to be looking at the discriminant test of identifying conic section. So say you have a conic section which has been presented in this form. Now, what we want is, can we actually identify what this conic section is? In previous classes, we sought to say that depending on what you have, sometimes you might have to first eliminate the cross product. After that, complete the square so that you first express that conic section in standard form, then you can identify what it is. But in this class, we're going to look at a method of identifying the conic section right at this point without having to complete the square or eliminate the cross product. Now, how does this method work? Well, this is what we're calling the discriminant test. And here's what you should look out for. So they're basically just pointers that you need to remember. These you have to memorize. They won't be given to you in a test one exam. Altogether, we're going to look at 3. Well, firstly, we have something that looks like the discriminant. Of course, this is discriminant, the discriminant of a quadratic equation. And if you recall, it takes the form of b squared minus 4ac. Usually, this is a discriminant, the discriminant of a quadratic equation, if you guys remember quadratic equations. But here, of course, a will be this, b will be this coefficient here, the coefficient of the cross product, c will be the coefficient of the y squared term. Now what happens? See, if you can get the coefficients and use them to evaluate what this is, all you're going to do now is check. You need to check for 3 things. Firstly, once you get this value, when you evaluate it, what will it give you? Well, here's the first thing. If let's say when you evaluate this expression, you end up with a value that is equal to 0. If you end up with a value that is equal to 0, then your conclusion is that you are dealing with a parabola. But if when you evaluate that expression, which is this, you end up with something that is less than 0, then your conclusion is that whatever the conic section is an ellipse. And lastly, if let's say when you evaluate, you end up with something that is greater than 0, then your conclusion is that you're dealing with a hyperbola. So this is what you need to remember. So what this does is it actually means that provided you have something in this form, you don't have to eliminate the cross product. You don't have to complete the square. You can actually identify the conic section by just evaluating what this is. Once you evaluate, make a comparison, and then identify the conic section. You only have to eliminate the cross product or complete the square if the question now requires you to say, express it in the standard form, or maybe sketch. That is when it will now be necessary for you to complete the square. Otherwise, in terms of just identifying the conic section, you can actually just use these expressions to identify what you're dealing with. Let's look at an example 1 or 2 so that you guys can actually relate this. So we can actually start by using the conic sections we have already worked on so that we'll just compare if this agrees with what we have been finding. So we can start with this one. This is a conic section that we worked out in our previous class on rotation of symmetry, rotation of axis, sorry. Let's see if we identify the conic section after I think here I just found the angle for you. We did not go all the way to identify it. I just showed you guys how to get the angle. So let's find one that we actually worked out to the very end and identified, this one here. So I think this one we worked it out until we identified what it was. I think this is a different question. So we can get it from here. I think that was the same question. So this is one conic section that we worked out, or that we dealt with. So when you look at this, we eliminated the cross product by rotating the coordinate axis. And then after simplification, we concluded that we arrived at this point, I think in this form. And then this is where we ended up with our conclusion that we were dealing with an ellipse. So this is after eliminating the cross product, and then after that, completing the square. Now, no, we actually didn't have to complete the square here. But let's see if we will come up with the same conclusion that we're dealing with an ellipse. So what do we need? So here we need to identify A, B, C. So we're going to evaluate what B squared is minus 4AC. So let's see. Our A is the coefficient of the x squared term. In this case, our A is 1. Our B is the coefficient of the cross product. And here we see that our B is negative root 3. And lastly, our C is the coefficient of the y squared term. In this case, our C is 2. Once we have these figured out, we can then now substitute. Our B squared implies that we have negative root 3, and this has to be squared, minus 4. Our A is 1, and our C is 2. So when we wrote this, the negative becomes positive, the root 3 becomes 3, minus, this becomes 4 by 2. This becomes 3 minus 8. This becomes minus 5. So what are we seeing? We're seeing the case where when we evaluate B squared minus 4AC, it's giving us a value that is less than 0 because negative 5 is less than 0. So what do we see? When we come back to our checklist, when we get this term being less than 0, our conclusion is what? We're dealing with an ellipse. And you see that we arrive at the same conclusion as we found after expressing the conic section in standard form, or in the respective equation. So we see that we are arriving at the same conclusion. Let's find another example, something that we did as well. Okay. So for this one, we did not really work it out to the very end, but I'm saying is that even without going all the way to the very end, we can still identify what conic section this is. And all we need is to figure out what B squared minus 4AC is. In this case, our B is 72. So we have 72 here, have to square it, minus 4. And then we need our A is 73. And then we need our C. And our C, in this case, the coefficient of the y squared term is 52. So when you solve this, what are you going to get here? So all in all, when we evaluate this, we're getting a negative value. So if we're getting a negative value, it implies that we are finding that this expression is giving us something that is less than 0. So as long as it's giving something less than 0, then we conclude that if you check our checklist, then that is an ellipse. So if we have less than 0, we have an ellipse. So this is what we have here. If we end up with greater than 0, then we're dealing with hyperbola, and so on. For practice, you can try to see if you can use the same approach to identify this expression. So you have 6xy plus 3y squared plus 2x minus 7 is equals to 0. So you have this conic section. Can you use the discriminant test to identify what this conic section is? And if you can you also try, this is going to be later on your own time, also try also to eliminate the cross product and see what you're going to have. It might be a little bit tricky, but try to see if you can find or come to the same conclusion about what the conic section is using the two different methods. Okay, so now we can move on to the next concept.